Oh, hi. If you're showing up for your learning to see a summary of all the transformations we've looked at, you are in the right place. If you don't want that, you're in the wrong place. No, you're all in the right place. All right, so let's take a look. If I have f of x as some function, and I'm going to transform it by multiplying my outputs, multiplying my inputs, subtracting from my inputs, or adding to my outputs, all of those a, k, c's, and d's are going to do stuff to my functions. When a is less than 0, that creates reflections. So what's the explanation here? It reflects in the x-axis. When a is less than 0. So when a is negative, it flips the function over in the x-axis. Okay? And then when a is between 0 and 1, like a is a number like a half or a quarter, it's a compression. So it compresses vertically. And then when a is greater than 1, it's a stretch. And it stretches vertically. So how does it map xy? Well, xy will map to x a times y. That's how your points are going to change. Your function is going to change its vertical dimensions. Its roots, or any points that are touching the x-axis, will have y values of 0. They won't move. They won't change. K, on the other hand. Oh, K is the trickiest one of the whole unit. Am I right? Am I right? K transformations are even trickier than the bonus question this week. Oh, imagine, visualize is the road to a solution here. Work on your inverses and visualizing those things, and you can solve that question. But we're talking about K transformations. When K is less than 0, this is also a reflection. But this time it reflects in the y-axis.
I'm going to scorekeep a Ogo game.
Okay.
There you go.
Yeah, that sounds like math. Okay, if k is between 0 and 1, like k is a number like a half or something, this has the opposite of effect of an A transformation, and it's operating horizontally. This is a stretch, and so this is a horizontal stretch. And when k is greater than 1, it's a compression, and a horizontal compression to be exact. And the overall mapping of xy, well, that's going to map to x divided by k, and your y values are unchanged. D and C are a little bit easier to understand. D is going to be moving things horizontally and moving the whole shape without changing the shape at all. So when D is greater than 1, we move right. And when D is less than 1, we move left. But there's an important thing to remember here. We have to sign flip exactly once. Don't sign flip twice, because that's the same thing as not sign flipping. So sign flip once. What do I mean by that? I mean that when we look at D, we think about it as having it sign flipped in the formula. That's how I've been trying to talk about it. I struggle with talking about that consistently. I know that when I look in here at D, that I'm going to see X moving in the opposite direction of this overall minus D. I flip the sign when I pull it out to call it D. Okay, so this is rightwards translation. And this is leftwards translation. Okay. These are also translations down here for C, but we'll use them in another color, green. So these are translations. When C is greater than 0, then we have upwards translation and downwards translation. Your overall mapping XY is going to go to X, Y plus C, and it's going to go to X plus D. But remember, we've flipped the sign of D already. Y. Okay. So what's the overall mapping of XY? Well, we're going to have, I'm just going to do X and Y in black and then show you all the different colors here. So X is going to be there, and Y is going to be there. But A, we were looking at A with blue, so let's grab our blue pen. So we're going to have A multiplied by Y. We have K dividing X. We use purple for D. So we're going to add D to our X after we've divided it by K. And then green was C. So we're going to add C to our AY. And that's the summary of all the transformations that we've looked at. And that's how they go. Any questions about any of those? All right, cool. So the secret word is emu. If you email me the word emu, it means I know you weren't in class and you watched this video till this point. Okay. Bye for now, everyone.